Hi everybody, my name is Alena and I am part of the education team at the MSU Museum. Welcome to the second week of our virtual shows. When the museum is open, we do shows in our Science on a Sphere exhibit every Saturday, but since the museum is closed, we're going to be doing an online version of our Science on a Sphere shows using an app by the same people who made the exhibit, the National Oceanic and Atmospheric Administration, or NOAA. This week, we're going to use it to talk about weather. So the first thing we want to do is, if you don't already have it downloaded, you can download and install the SOS Explorer app if you want to follow along. I'm going to be taking us through a couple of the data sets, but you can feel free to explore the whole set of them on your own time. So to download it, you just search for SOS Explorer in the App Store of your Apple or Android device. It should look something like this. And I can pull my app up. So the app is loading. On the left-hand side, we have a list of all the data sets that we can load. So there's a whole bunch of them. We got stuff from bird migration patterns to, carbon dioxide concentrations. So a lot of cool information. Another cool feature is in the bottom right-hand corner, the 2D, 3D button. Sometimes it's easier to see patterns if you can look at the whole world at the same time, but sometimes it's cooler to look at it in a 3D way. So let's get started with our program. The first thing we're going to talk about is the difference between climate and weather. So you check the weather every day, but we've probably also heard about climate change. Climate is basically just more general than the weather. It's how the weather is different all over the world. Weather is how the conditions outside change every day. If you want to learn more about climate and how we humans are affecting it, you can check out our climate clues program in a couple of weeks. For now, we're just going to focus on the weather patterns though. Some things affect the weather on a large scale, like global climate change or a cycle called El Nino that we'll talk about next week, or the seasons. Other things like air pressure, temperature, humidity, and wind, those all affect the weather on a smaller scale, and how the weather is affected can differ with the regions. The clouds, temperature, precipitation, storms, winds, everything you see outside with the weather, that's basically a result of interactions between global systems and local conditions like geography, latitudes, where we are on the Earth, moisture levels, and then solar energy absorption. So how much sun is hitting the place where you live and how much of that is actually hitting the ground where you live. So we can pull up our first data set of today's program. I'll go to the land category and then scroll down to surface temperature. Land surface temperature. Land surface temperature. Not light pollution. That's a cool data set to look at too, but today we're going to look at land surface temperature. All right, so I'm going to put it in 2D, but you can feel free to look at it in whatever format you want. So you can see the patterns here. It's going through a year from February of 2018 to 2019 is where this data is coming from. And it's going through the seasons, so you can see when we get into October, November, December, the Northern Hemisphere is winter. The US, Russia, you get a lot more of the blue color. Antarctica is pretty much dark blue all year round. We expect that. So that's the cold times, the cold regions. The equator, though, is staying pretty bright orange, almost red, for the entire year. The equator is warm year round because it gets a lot of that sun. The northern hemisphere and maybe the southern part of the southern hemisphere, they vary more with the seasons. So if you live in northern Canada, where it's blue basically all year round, you would have a couple parkas. But if you live at the equator, you just own a lot of shorts, that kind of thing. Precipitation is another part of the weather, so that's rain, snow, hail, all of that stuff. Precipitation forms when the sun heats the air near the Earth's surface, and then that warm air rises. As it rises, it cools and condenses. It forms clouds, which then further condense into water droplets that fall from the sky and fall on us as snow if it's cold enough, or rain. If we want to look at a data set about the clouds and precipitation, we can go to the air category and scroll up to clouds. The Colorado flood one, it's pretty cool. It's just looks at the clouds during a flood in Colorado in September 2013. I like to look at the clouds with precipitation, the bomb cyclone, from March 2019 data set though. So you can zoom in on Michigan if you'd like, the US, So basically, a bomb cyclone is a super low pressure storm that's basically a winter hurricane. So you can see the swirl kind of moving across the country there, dumping a lot of precipitation on us as it went. You can see it right there. If you look at the whole world view, though, you can see how precipitation type and amount differs all over the world and with different cloud concentrations, the different cloud types. The equator only has the green, yellow, and red colors, so it's just rain of varying amounts. None of the snow, that's the blue and purple of the far north and far south of the globe. In the US, with that bomb cyclone, you get a mix of rain and snow depending on what part of the country it's in, what time it was during the storm. But this is all during a month in March, so it can be cold enough to be snow in some parts of the country, but maybe not all of them. So depending on the temperature or geology of an area, basically precipitation can fall in different ways. And this data set shows how much and what type of precipitation fell during this period of time. Another example of how precipitation falls is through lake effect snow, which is an example of how air and the Great Lakes can interact to create a weather event. Let me pull up my slides for a diagram of this. So basically, cold, dry air blows over the warmer water of the Great Lakes. It picks up a bunch of that moisture, that warm moisture, and then as it gets back over the cold land, it dumps a bunch of snow on the other side of these lakes. Another example of how air and moisture circumstances interact to create major weather events is in thunderstorms. So those are generally more common or more widespread than lake effect snow. And then I have a short video that can explain how thunderstorms form.
You've probably seen a big thunderstorm cloud roll into town, and the thunder, lightning, heavy rain, and gusty winds are hard to miss. But where did that thunderstorm come from? All thunderstorms follow the same recipe. To form, these storms require 3 basic ingredients: moisture, unstable air, and lift. Moisture in the air typically comes from the oceans, and areas near warm ocean currents evaporate lots of moisture into the air. Moisture in the air is also responsible for making clouds. Unstable air forms when warm, moist air is near the ground and cold, dry air is up above. To create a thunderstorm, the unstable air needs to have a nudge upward. This lift usually comes from differences in air density. Warmer, less dense air rises upward, creating lift. As the air lifts higher and higher, it causes the storm cloud to grow taller and taller. Thunderstorm clouds can rise up to 10 miles into the air. In a big thunderstorm cloud, there are now strong upward winds and downward winds happening at the same time. These are called updrafts and downdrafts. This is the most dangerous stage of the storm, when tornadoes, hail, winds, and flooding can happen. Updrafts continue to fuel the storm with warm, moist air. But once a storm runs out of updrafts, it starts to weaken. As the storm begins to slow down, the rain and wind become less intense. And by the end, all that's left is a blue sky and an anvil-shaped cloud top. Phew! Glad that's over. Sure, the storm will probably come again, but you don't need to worry. Forecasters can use weather satellites, like those in NOAA's GOES-R series, to monitor clouds as they grow into thunderstorms. GOES satellites watch out for lightning, too. These satellites are constantly watching for severe weather, and the information they gather can help people stay safe during storms. Find out more about Earth's weather at NOAA Sijinks.
Alrighty, so we'll talk more about those weather satellites later on in today's program. So another part of the weather is how warm or cold a day is. So it mostly depends on how much energy we're getting from the sun. So how much energy is coming from the sun and how much of it hits the earth. So we can bring up our app again. and go to space and bring up a data set about the sun. So scroll down to sun. I think the helium wavelength one looks cool personally. You can also check out the X-ray data set if you'd like. So the sun doesn't have an atmosphere, so it doesn't have weather like we do. It's just a giant burning ball of gas, but it does have patterns in how those gases are burning. You can see them moving around. Some spots are brighter than others. We get solar flares. That's kind of the sun's version of weather. But what really affects us on the Earth is the 23-degree tilt of the Earth as it rotates around the sun. So what part of the Earth is closest to the sun determines our seasons. So the Earth is tilting, and you're on the part of the Earth that's close to the sun for longer parts of the days, then you are getting you have your spring or your summer seasons. Additionally, the number of clouds that are over an area of land can affect how much the sunlight actually hits the ground. So it's not just how much sun is coming towards your part of the Earth, but how much it is actually getting to the ground. Cloudy days usually feel colder than blue sky days because the clouds reflect more of the solar energy into the sky instead of it letting it come down and hit the ground. Alrighty, so we're going to bring up our last data set for this show. So what moves clouds? That would be the wind. The wind is another part of our daily weather, but it's also part of a global system. So it can be really windy outside, or the air can be very still, but wind can also blow particles from one part of the world to another. So if we go to the air category and scroll up to atmospheric chemistry GEOS 5 model. This is just a model. It's not done with real data, but it's constructed using real data. All right, we got that loaded. So this is the atmospheric chemistry model. So it's showing how the wind is blowing particles through the atmosphere. So you can see the sea salt, the blue, is mostly from the oceans, especially in the southern hemisphere. Sulfate is basically a generic term for air pollution. So it's coming off of the big cities like Eastern United States, Europe, Eastern China, Russia. Those areas have a lot of the sulfates coming off of them. Dust is pretty cool because you can see it blowing off of the Saharan Desert, the Sahara Desert, and kind of like that region of the Earth, and kind of blowing over into South and Central America. So you get a lot of particles that end up being deposited on the other side of the Atlantic Ocean. I think that's pretty cool. These aren't the actual colors of the data set of these particles, but since it's a model, I think it's cool to look at. The last part of this program is talking about some tools that we use to measure the weather. Move back to my presentation. Scroll through. All right, so the video about the thunderstorms talked about weather satellites. So scientists like those at NOAA can use weather satellites to take a look at what's going on all around the world. This is especially helpful for seeing fires and hurricanes and predicting other big events. There are other smaller tools that we can take, you could use a little bit closer to the ground though. This is a pretty common one. It's a thermometer, right? So you might use this to take your body temperature, but use a different type to take the temperature of the air outside, maybe in your house. Another common one is wind vanes. So you might see these on the tops of houses, barns, that kind of thing. And that just tells you which direction the wind is blowing. Another part of the wind is how fast it's blowing, which is measured by something called an anemometer. So this is a cup anemometer. Wind blows into the little cups and it moves the anemometer around, and that tells us how fast the wind is blowing. A barometer yeah, there you go. A barometer is used to measure the pressure in the air. So I mentioned that a bomb cyclone is basically a really low pressure storm. So usually low pressure corresponds to big storms. Like this barometer has different little pictures showing what the weather's probably going to look like with an air pressure of that type. So with this air pressure that this barometer is showing, it's probably maybe a little drizzly, kind of cloudy, something like that. Um, Another tool is called a hygrometer. So there's a couple different types of these. Um, Most of these things you can get pretty high tech with them now. You can get like your own digital weather system. A pretty simple one though is the rain or snow gauge. If that will load, give it a minute. There we go. So basically, it's just a cup with some measuring marks. You can check it every day and see how much rain fell the night before, that kind of thing. So a lot of these tools you can look up on the internet how to make your own. Most of them are fairly simple, but the simplest one that we have is actually our eyes. So if you look outside, you can see if it's cloudy, sunny, if it's raining, if there's a thunderstorm, if there's some lightning off in the distance, you can see, look up at the clouds, see if they're blowing in your direction. That's a pretty good sign that you're going to have some rain yourself in a little bit. Um, Scientists called meteorologists use all these tools to measure the weather and then use that data to predict what weather will happen next. And that's where our weather forecast each day comes from. If you want to, you can actually become a citizen scientist yourself and help collect data about the weather where you live. So you want to, you can go to this website, scijinx.gov/CocoRoz, and you'll learn more about the Community Collaborative Rain, Hail, and Snow Network. So basically what this program is that you set up a rain or snow gauge, and you check the weather outside every day at the same time, maybe in the morning or the evening. And then you record that data on this website. So it's pretty cool. You can actually help the scientists figure out the weather, the climate in your region just by doing something small every day. So that's all I have for the program today. Feel free to ask any questions if you're watching our Facebook watch party. Another option is to check out the MSU Museum's virtual resources, museum.msu.edu. There's a banner at the top of our website that has links to different resources, activities that you can do at home. All right, so I encourage you to make your own weather research tools. Maybe just take a look outside, maybe keep a weather journal, take a break, take a walk, enjoy the weather that you have wherever you are. Maybe take those observations a step further and help researchers out by becoming a citizen scientist. I hope that you have a great rest of your day, and we hope that you'll come back for another video next week.